Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have been discussing about the electronic configuration and we have discussed about the electronic configuration of the first 5 elements, that is up to boron. So again, let us continue with that. We will be discussing the electronic configuration of the other elements up to atomic number 20. Okay, fine. So let us carry on. So let us see. So atomic number. Okay. So let us now consider the sixth element. So sixth element, what is the sixth element? It is carbon. Hydrogen, helium, lithium, beryllium, boron, carbon. So sixth element is carbon. So it is a atomic number of 6. So let me write these shells above. K, L, M, N. Okay, fine. Now carbon has 6 electrons, as you can see. So if I consider the 6 electrons, how will be distributed? First 2 electrons will be present in the K shell, then the next 2 electrons, 4 electrons will be in the L shell, 2, 4. Then after carbon it's nitrogen. So nitrogen is atomic number 7. So it will be 2 and then 5. Fine. Then after nitrogen it's oxygen, atomic number of 8. It will be 2, then it 6. Fine. After oxygen comes fluorine. So atomic number 9, it's 2 and then 7. And at number 10 comes neon, atomic number 10. So it's 2 and then 8. So if I see this chart, you can see that carbon has 4 electrons in its last shell, nitrogen has 5, oxygen 6, fluorine 7, then neon has 8. So again I will be marking the element neon. Okay, see this element has 8 electrons in the last shell, isn't it? This element is actually a noble gas and it has 8 electrons in its outermost shell. This structure is referred to as the octet structure. Octet structure. Yesterday on the previous class we have discussed about the duplet structure. Duplet structure was for the helium, as you have seen. Now neon has 8 electrons in the outermost shell and is called the octet structure. And if we consider from carbon to fluorine, all these elements are basically non-metals. So you can consider that non-metals generally have 4, 5, 6 or 7 electrons in their outermost shell. So these are the facts that you have to remember in order to identify the element into metal or non-metal. Okay, fine. So now let us move on to the next 5 elements. Okay, fine. So the next 5 elements, what are the next 5 elements? Neon. Then after that comes sodium. Okay. So next comes sodium. Sodium has 11 atomic number, so it will be 2 in the first shell. See, now the second shell can have a maximum of 8 electrons. So I cannot place the remaining 9 electrons in the L shell. I have to place it in the next shell. So I will put 8 electrons in the L shell. Then in the next M shell, the remaining 1 electron will be placed. So it will be the configuration will be something like this: 2, 8, 1. Okay, fine. Then comes the sodium, then magnesium, atomic number 12. So it will be something like this: 2, then comes 8, and the remaining 2 electrons in the M shell, 2, 8, 2. Magnesium, then after that comes aluminium, 13. So it will be, you can very easily understand, 2, then 8, and then 3 electrons in the outer shell. After that, after aluminum comes silicon. Silicon has an atomic number 14. So it's 2, 8, and then 4. And after silicon comes phosphorus. So 15. So it will have 2, then 8, and then 5 electrons in the outermost shell. Okay, so here you can see that the first three, sodium, magnesium and aluminum, these three elements are basically metals. Why metals? Because see, they have 1, 2 or 3 electrons in the outermost shell. In the previous class we have also seen that the metals, the elements which are classified as metals, the elements which shows metallic properties have 1, 2 or 3 electrons in the outermost shell. Whereas the non-metals, these two are the non-metals. The non-metals have 4, 5, 6 or 7 electrons in the outermost shell. So here you can see 4 and 5. Basically 4, if any element has 4 electrons in the outermost shell, it is better to classify it as a metalloid. Okay, so silicon, carbon though has 4 electrons in the outermost shell, it is regarded as a non-metal because it has properties purely related to non-metals. However, this silicon, I must rectify this here, this silicon is actually a metalloid. Okay, because it has properties both close to metal and non-metals, some properties of metals and some properties of non-metals. So I think the concept is clear. Fine. Then next move on to the next 5 elements. So first for us 16, at number 16 comes silicon. So come to element number 16, sulfur. So sulfur 16, so it should have configuration like this, 2, 8 and then 6. After sulfur comes chlorine, Cl 17. So it will have 2, 8 and then 7. After that comes argon. This is a noble gas. So this has configuration of 2, 8 and 8. Then comes potassium, 19 atomic number. Then see 2 electrons in the first shell, then 8 electrons in the next shell. Now how many? 2 plus 8, 10. How many more electrons left? 9. Third shell can easily accommodate 18 electrons, maximum 18 electrons. So I can easily put here 9, isn't it? Yeah. But this is wrong. Why this is wrong? Because that is another rule which says that the outermost shell, if I take this configuration, this is the outermost shell. The outermost shell cannot have more than 8 electrons, isn't it? The outermost shell cannot have more than 8 electrons. So what I can do, I have to basically put 8 electrons here. So now this becomes my penultimate shell, and the remaining 1 electron will move to the next shell, that is the end shell. Okay, so something like this. So the configuration becomes like this. It's 2, 8, 8, 1, and lastly it's calcium. Calcium has an atomic number of 20. So 20, it's 2, 8, 8 and then 2. So I hope you have understood why we are not putting 9 electrons or 10 electrons in the third shell, although third shell can accommodate 18 electrons at the max. Because the contradictory rule says that the outermost shell cannot have more than 8 electrons. So this is the electronic configuration. Here also you see this argon has 8 electrons in the outermost shell. This is a noble gas. So this is a noble gas and it has octet structure. 8 electrons in the outermost shell. So it is octet structure. Why I am writing this? Now I will explain. See, octet structure. Whereas the above two, these two have 6 and 7 electrons. These are non-metals. And the remaining last two, these are 1 and 2 electrons. So these are the metals. So I hope you have got some clarity regarding the classification of elements, metals, non-metals or metalloids, okay, and the noble gases. Fine. Now remember one thing, all the elements, the atom of all the elements, what they do, they try to attain the electronic configuration of their nearest noble gas. Note down these words. If you have, you must have pen in your hand and copy to write. Please note it down that every element tries, the atom of every element tries to attain the electronic configuration of the nearest noble gas. So from this I can say that potassium will try to attain the electronic configuration of argon. Chlorine will try to attain the electronic configuration of R1. Okay, but there is another noble gas, neon. It is having an atomic number 10. Calcium will definitely not try to attain the electronic configuration of the neon. Remember this. Okay. Now, why these elements try to attain the electronic configuration of the nearest noble gas? Because, note it in your copy. Because noble gases are stable elements. The atoms of the noble gases do not react. That is why they are named as noble gases, inert gases. Okay, so they do not react, they are stable. So everything wants to attain stability, wants to have stability. That is why these elements, potassium, calcium, chlorine, sulfur, these are quite reactive. Why they are reactive? Because they are not stable. So in order to attain stability, they try to attain the electronic configuration of the nearest noble gas, and that is why there are reactions. We will be explaining it in later class. So just remember these things what I have said in previous class. Okay, with that we come to the end of our class. We will be continuing with these topics on the next class. Please do go through these videos. If you have any query, mention it in the comment box. We will be happy to solve your problem. Thank you. Goodbye.